Okay, suppose we sell 100 sandwiches for $5 a piece. The question is, what's the natural calculation that goes with this situation? You should think what that calculation is. Pause if necessary. I'm going to tell you though. Okay, well, the natural calculation is 100 sandwiches times $5 per sandwich equals $500. Now you might not have written it out, sandwiches in dollars per sandwich, but you would have done the equivalent. You would have multiplied 100 by $5 and gotten $500. That's the natural response to that information. So we have price, demand, and revenue. The price in this case is $5. The demand is 100 sandwiches. If there wasn't a demand for 100 sandwiches, we wouldn't have sold 100 sandwiches. And our revenue is the money we took in. Now there are other important functions here. We could have cost and profit. These are other important things. Our revenue is not our profit because it cost us something to get or make these sandwiches. What's our profit? Well, profit would be our revenue, the money we took in, minus whatever it cost us to make or purchase these sandwiches ourselves. So we're not going to talk about these things right now. They're not part of this question. But those are two more important quantities, and they're related to the revenue in an obvious way. The revenue minus the cost equals profit. So you might store that away. Back to the topic of the current problem. Let's motivate it by, thinking about how price and demand are related. Okay, if we charge $15 for these sandwiches, you think we're going to still sell 100 of them? Well, that depends on how hungry and how rich our clients are. But we expect that as we increase the price, the demand is going to go down, so that price and demand will have opposite trends. Bigger the price, the less the demand. Bigger the demand, the less the price must have been. So we're going to let P equal price, X equal demand. And we have the following, the problem that we're looking at actually has price equals negative 2.75x plus 500. Now, we could solve this for x, and we get x is about 0.35 times p, and it's going to then be plus about 180 or something like that. But we're not going to do that. I would simply accept this. What I'm going to say here is that with the negative 2.75 in front of x means that the greater the demand, the less the price must have been. Because the bigger x is, the bigger negative number this is going to be to add to the 500. Okay? We would normally think more in terms of how x depends on the price, because the price is the thing that we vary, but this is what was given. So we have this relationship between the price and the demand. Now, how are price and demand related to revenue. Because the question now, it asks, what's our revenue function? So what is revenue? Well, as we see from our example, to get the revenue, we multiply our price by the number we sell, or the price times the demand. So revenue revenue equals price multiplied by demand, or R equals price times X. If the price is this, then our revenue is going to be negative 2.75x plus 500 multiplied by X. So here's our revenue function. What kind of a function is this? You should think about what kind of a function this is and how we're going to deal with it. Okay, well, this is a quadratic function, because when we multiply through by x, we get negative 2.75x squared plus 500x. So now our revenue equals negative 2.75x squared plus 500x. Now, if we wanted to maximize the revenue, what we do is we take a graph of the revenue versus X and find the highest point on the graph. What kind of a graph do we get if we graph the revenue versus X? Well, this is a quadratic function. It's got a squared term, an X squared term, and an X term. Doesn't have a constant on the end, but that's perfectly legal. This is a quadratic function. Okay, it's a quadratic function, so it has a parabolic graph. And the coefficient of x squared is negative, so the graph opens downward. So we have some sort of an upside down parabola. The peak of that parabola will represent the point where the revenue is maximum. Now, I'm not going to go through the details of how we graph this function. We've seen plenty of instances where we graph parabolas. I'm simply going to state the result. The zeros of this function are at x equals 0 and x equals approximately 182. And we can get that easily enough. If we factor the 2.75 out here, we get 2.7. Let's factor x out. Okay, factor x out of here. We get x times negative 2.75x plus 500. If we also factored out the 2.75, we would get inside the parentheses the 182. Okay, it would be negative x plus 182 approximately. But axis of symmetry is halfway between the zeros, and this is the line x equals 91, approximately, rounding to the nearest whole number. And the peak of the graph will then occur on this axis of symmetry at the vertex. I didn't draw that very well. So we plug 91 into the revenue function and we'll get the maximum revenue. I'm just doing this for point of reference. We could also have used the quadratic formula. The negative b over 2a would be negative 500 over 2 times negative 2.75. That gives us about 91. So those techniques would be used to find the maximum of the revenue function. Again, that wasn't asked on this problem, and that technique is addressed elsewhere, so I'm not going to repeat it here. I'm just going to give you the result, and you can kind of verify that for yourself.